This episode of the Cloudcast is sponsored by ServiceNow. ServiceNow is changing the way people work. With a service orientation towards the activities, tasks, and processes that make up day-to-day work life, ServiceNow helps the modern enterprise operate faster and be more scalable than ever before. To learn more about the enterprise cloud built to manage everything as a service, please visit www.servicenow.com. And now, on to the show.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast, coming to you live from the massive studios here in Raleigh, North Carolina, on a very, very hot, humid summer day out here in Raleigh. Aaron, how are you? Welcome back to the show.
Yeah, doing great. Really nice to actually be back and kind of getting back into it. Things got a little crazy busy with work again. But no, we're between that and the upcoming Jeffcast, some of the work going on that. I had a DNS breakthrough moments before the show, so everything's kind of moving along nicely right now. Yeah,
and we're still expecting to get that out here. Give us a few more days to kind of work out a few kinks, and then lots of good stuff come on the serverless side of things. But tonight, Aaron, do you remember the very first show we had where we said we only have one mission, and that's to go find people that are much, much smarter than us and bring them on the show?
Yes. Yeah. And tonight we've done that without a doubt.
Yeah. So tonight we're very excited to have James Cowling on from a storage lead at Dropbox. James, welcome to the show.
Good day, guys. Thanks for having me here. It's very charitable of you to give that introduction, but it's nice to be in the show with you guys.
Yeah. So before we get into kind of what we're going to get into tonight, and give folks a little bit of your background, because it is it's not only is it very timely in terms of you guys just had a huge article written about you and so forth, but in terms of people talking about distributed systems and what's going on with internet scale stuff. Give folks some of your background and kind of how you what you were doing and how you got over into Dropbox.
Yeah. So I grew up in Australia, and I've always been into tech. I've always been a kind of a tech guy. But I came out here on exchange to the US, back in 2002, and realized I kind of liked it here. So I came back to the US again later on, did a master's and a PhD over at MIT, where I specialize in distributed systems. And since then, I kind of had this kind of fork in the road, whether to stay in academia and be a professor. And I decided, you know what, I want to spend some time getting my hands dirty. And so I've been at Dropbox for the past 4 years. But, I guess being here, what's exciting to me, if you look at the cross-section of the team I work with, we have the same number of PhDs as college dropouts. So there's a very broad background, and I can tell you the college dropouts are usually a lot smarter than me. So it's I wouldn't say my background is at all a prerequisite for doing this kind of work, but I have spent a lot of time in a past life, researching systems, storage systems, that kind of stuff.
Yeah, no, that's that's fantastic. That's great. So, a lot of folks had an opportunity. You guys made a lot of noise. A few months back, Wired Magazine wrote a great article about, kind of I think it was called sort of the exodus from AWS, but it was a really good piece about, why Dropbox from both a business perspective, but then this huge technical challenge of basically moving your business, a core part of your business, from, a very large public cloud provider to bringing, big pieces of it back in house, the equivalent of, changing the tires on an airplane or changing the wheels on the wings on an airplane when it's flying. Give us some of that background of, how the idea got started. What were some of the big thinking that went on behind all this? Give folks some color behind maybe what they might have read in that Wired piece.
Yeah, I'm in an interesting position because I've been kind of branded as the guy kind of advocating for in-house infrastructure, and that's what I do. That's what my job is, and I work on the storage system here at Dropbox. But simultaneously, I'm also a big advocate for cloud services, right? And Dropbox has always been a huge customer of cloud services, in particular of Amazon. And so if you go back to kind of 2007, the early days of Dropbox, we had this kind of one of the pioneers of this hybrid model where we had all of our block storage, so what we call block storage, basically the big blob store that stores the file contents. That's always been in Amazon S3. since very early on in the company. And we've had our own data centers also since very early on in the company, which contained all our business logic. So all our metadata, all our application services, our databases have always been in our own data centers. And so Dropbox has always had the attitude of, leveraging third parties where it makes sense. And for us, that meant, a lot of our, being able to control our databases, being able to control our application services made a lot of sense from early on. Being able to leverage Amazon scale for the storage, because it's a pretty big challenge to build kind of exabyte scale storage. It made sense for us to leverage off Amazon. And plus, we've got plenty of other services that we run on AWS, SQS and SES and SMS and a whole bunch of acronyms that start with the letter S and end with the letter S. But there came a time where it started to make sense for us to run our own storage. And it's not a decision that I would necessarily advocate for in general for companies. Dropbox is in a very unique place. One where we have an absolutely mammoth amount of data. I think we've gone public in saying we have over 500 petabytes of user data. We have, over 500 million customers. And a big part of our business is storage, storage and collaboration and sharing, that kind of stuff. So it made sense for us to start investing in running this in-house. Obviously, in terms of resource utilization and financials, it makes sense for us, only at that very large scale, but primarily from a technical perspective. So, having been at Dropbox for a long period of time, I have a very good sense as to what the average block size is. The average object size we store is 1.6 megabytes, and I know exactly what the distribution of those accesses look like and what data is hot, what data is cold, and where those users are located and what times they're accessing this information. So that allows us to kind of build a storage system that's very closely tailored to our use cases. And that's where it starts to make sense for us. So I think for us it makes sense only when you have a combination of economies of scale, absolutely necessary. It's really difficult to build a system of this scale, without a very large infrastructure basis to justify the investment. You need to have a very good understanding of your workloads and a motivation for doing things yourself. And you also have to have the talent, right? We have to build up a team. And so when I got to Dropbox, infrastructure, I think, was 7 people, the entire infrastructure team. And so it was a pretty big undertaking back then to start building a storage system. And from then onwards, it really required ramping up the core team, but also hiring people that at the time I didn't even know, roles I didn't even know existed. Stuff like supply chain teams and capacity engineers and hardware engineers. And we have folks who specialize just in hard drives. And so, we had to, it was a big shift for the company, technically in terms of taking on a big technical challenge, but also organizationally. We had to hire a lot of very experienced people. But ultimately, the company's a lot better off for it because we've managed to kind of increase our talent basis now. Now that we've built what's ultimately a multi-exabyte storage system across at least 3 geographic regions, we have the capability to build a lot of other systems internally as well.
Oh, that makes sense. And so if you call, again, the code name of this was Magic Pocket. If you go read the Wired magazine article, and we'll link to it in the show notes. But so let me ask you this then. There's always kind of lessons learned as you're going through and also, of course, afterwards. But so what went right and what went wrong and what surprised you in all of this? Yeah.
I'll start with the surprise one because I'll reflect on my personal experience. When I was doing a thesis on distributed transactions, I was never thinking about how many racks of hardware will fit on the loading dock at a given point in time, right? And there was a period of time in the project where we were scaling up so rapidly that our bottleneck was literally how many racks we could get off of trucks and into our data center at a given point in time. We would bring up 30 to 40 racks full of storage hardware per day. So these kind of extremely practical concerns. I remember speaking to our folks in the data center, and we kind of designed deployment plans for how to bring up racks. Let's say you have 16 racks come into the data center, what rows should you put them in to provide the maximal amount of physical diversity? You want to have these on different circuit breakers and different power distribution units. And, having conversations like, hey, we have this plan, but we just can't Tetris these racks to the data center fast enough to keep up with this scale. So these very, very practical concerns. I guess some of the things that you just wouldn't naturally foresee until you've done it. But what went right? I mean, fortunately, a lot of things went right in the project, and we executed ahead of schedule and under budget. I think what we did well was we invested very, very heavily in verification systems and testing and validation, and gave us a lot of confidence that the system would run and be correct, and also invested very heavily in automation. We have many hundreds of thousands of disks in production, and we have a team of around 4 people who kind of oversee all operations with respect to the physical hardware on the software side. And so the only way you can manage that kind of volume of hardware is by having a lot of pretty advanced automation, and that's one thing we invested well in. In terms of things that could have done better, it's a hard question to answer. I think in hindsight, things actually went pretty well. I think probably what we could have done is invest earlier on in experienced operational people. So there was a very early phase of the project where we were kind of really prototyping and just kind of messing around, trying to work out what the system would look like and what our workload was going to be, because we knew we were building a system for a workload we didn't quite yet understand. We hadn't run multiple exabytes of storage as a company. And so I think, investing in people early on who could have helped us, operationalize and automate a lot of our deployments would have been a very worthwhile investment. Of course, we ultimately did do this and hire these people, and they really leveled us up as a company. But I think that was the key. You might think that the hardest part of the system is the design, right, and coding it and implementing it, and that was hard. But we have a lot of really talented engineers with a lot of experience in systems and a big focus on simplicity and keeping things absolutely as simple as possible. And, that was this kind of rule in the team. Every decision, if there's a cool way of doing it or a simple way of doing it, you always go the simple way, because the complexity comes later on when you kind of try to deploy this stuff. And so we're fortunate to have got the design right and had a design that was flexible. And then the big challenges were kind of building out, scaling out, and operationalizing the system.
Yeah, no, a lot of that stuff, logically makes a ton of sense. And I think, when you talk about sort of the surprises of things like, you have to plan for supply chain, you have to plan for, things like power and cooling and stuff that you sort of know you have to do, but to do it at, either at pace or at scale is a different sort of logistics. It's sort of like, you could throw an event at your house like a party, but if you were throwing an event for a Super Bowl party, it'd be like a whole different thing because it happens once and it's 50 times the scale you're used to. And I'm very interested because, part of the thing that I think Aaron and I probably both have going on in the back of our mind is, we're trying to say, there are a lot of people who are trying to figure out, okay, here's somebody who took an application from, or at least a part of an application from the public cloud, moved it back into a place where, there was either better economies of scale or better operations. But you talked a lot about, the importance of automating things. And that's something that I feel like more and more people have to have front and center as opposed to doing afterwards. Is there any chance that if you hadn't been making in these investments around automation that any of this sort of would have worked even if the design was amazing and the software was amazing?
Absolutely not. And that was really the key. And I wrote a blog post about this. It's on the Dropbox Tech blog about verification systems, and that's something I put in a roughly similar category. And we have this kind of policy on the team of this concept of 100% correctness. At least, if I can ask the team today, is this system currently 100% correct, or is our data 100% valid and uncorrupted? And we have to be able to answer that question every single day. And to be able to do that, there's this huge stack of verification systems. And we spend significantly more effort building these verifiers than building an underlying storage system, or at least significantly more time. The storage system is more kind of technically complex to design and implement, but we have this big verification stack. And this is like absolutely critical to be able to have this kind of basis of trust and basis of proof within the system that you can rely on. So, for example, I'll give you an example on the two ends of the stack. The very lowest level verifier we have is called the disk scrubber. And this is a daemon that sits on every single node with every single disk. And it continually reads that disk back and checks every byte against checksums that we have on disk. And this scanner finds issues all the time. It finds errors all the time. These aren't software errors. It's not a bug on our end. But disks fail all the time. When you have hundreds of thousands of disks, those disks will fail. They'll get corruptions. They'll say they F-synced when they didn't F-sync. And so one thing you can do is sit back and wait for a corruption to bubble up to the application level, but then you're exposing yourself to this big window of vulnerability, during which time that you don't know that there's an on-disk corruption. So we have these scanners running constantly, trying to detect with very low latency if there is any on-disk corruption. If there is, we automatically kind of quarantine that data, re-replicate it elsewhere in the system, and then fire off an automated job to kind of remediate this disk. And what remediation means in this context is, just say there's a bad sector on a disk, and that means a byte's corrupted. We mark that sector as bad, and we keep using the disk for a few times. After a certain number of bad sectors have been detected, we decide, you know what, there's something wrong with this disk right now. Let's reformat that disk entirely and try it again. We reformat the disk, bring it back to production. We try that for a certain number of times. If that fails again, then we automatically kind of quarantine that disk again, and then take it out and physically shred the disk. That means actually taking that disk and throwing it into a giant shredder that will destroy that disk. And these systems are all entirely automated, and this is no way you could trust a human being to do this. We don't let an operator come anywhere near one of our disks if it has critical user data on that. So that means we keep all our data in these volumes. They're called volumes. They're kind of replication units. And so you might have a piece of data striped across 12 disks, for example. And if one of those disks fails, you can't touch that disk until all data there has been re-replicated elsewhere in the system. Then that disk is flagged as now that disk is safe to remove, and a ticket's filed automatically, and someone can go and pull that disk out. This whole process is automated. One, if it wasn't automated, we'd spend all day just dealing with this stuff. And two, if it wasn't, there'd be mistakes would creep in. That's just one level of the stack. There's probably seven verifiers the whole way up that we rely on very heavily to kind of enforce correctness.
That makes sense. And so something that interests me too is as I'm thinking this through, coming off of AWS and specifically coming off of S3, would it make sense then from an operational standpoint when we're trying to automate this as much as possible and doing some of these things, did you effectively almost rewrite that API layer to kind of make your own S3 emulator backend, or did you kind of recustomize the code, or how much it was involved with that transition away from AWS and their API specifically into your own private world?
Yeah, so if you think of the Dropbox architecture, on the very bottom of the stack is a storage system, Magic Pocket, and it's a blob storage system. So it's basically a giant key value store. It stores a hash of a block mapped to an encrypted block on disk. One layer above that storage system is something we call File Journal, and this is our actual file system. This is the system that stores, you have these files and you've shared it with these people, and these are the revisions, etc. So the actual rich file system is stored on a higher layer. So that higher layer didn't really change that much, and what it meant is like building a kind of a translation layer to allow us to use both systems concurrently. And we do use both systems concurrently on a per user basis. We have the option to decide whether to store that data on Magic Pocket or on S3. The interfaces aren't exactly the same, and we actually change our API a little bit to kind of better suit our use cases. It simplifies some of our logic. But yeah, basically we built this translation layer. Ultimately for us, I'm going to go on a little bit of a tangent here, but if you look at the kind of big infrastructure companies, who have built big storage systems in the past. Typically, these companies that have been around a little bit longer than Dropbox, and they evolved at a time where there was no cloud, right? There was no Amazon S3 to leverage. So they built these storage systems, and they did an incredible job of doing so from zero to scale upwards from there. And they had an opportunity to iterate and evolve as they went. For us, we had to build a system that from day one would store hundreds of petabytes. So, and we already had, 500 million users that we had to service. So for us, it was really critical that we were able to have a very kind of graceful transition from S3 onto our own storage, and to be able to do that migration without anyone noticing. It was obviously absolutely critical that no one would notice that transition. We were successful at that. There was no kind of user-facing degradation of service, and partly that came from this kind of pretty long validation period, which we call production validation, where we stored a significant fraction of our data on both systems simultaneously to have S3 as a backup while we made absolutely 100% sure Magic Pocket was ready to go at that large scale. And then once we determined that we'd signed off, then it was on. Then it was time to scale up as fast as possible, and that was this kind of big 6-month period where we moved approximately 500 petabytes of user data into the storage system.
Help folks understand some of this. I mean, anytime you ask any business to go through a transition, and you were just, you were going into detail there where you're saying, look, we weren't starting from scratch. We had this huge installed base of customers expecting something, and then, we're going to move to something you expected to be bigger. Give us a sense of, what were the, you're going to have, business side of the house people kind of banging on certain metrics they care about. Are we more profitable? Are our costs lower? Is our customer experience number? Give us some sense of the insight of kind of the trade-off that was going on, or the prioritization that went on between the business people at Dropbox and the technical people who were going hang on, let us just get this one more feature in there, or we're going to get there at some point. Hold on, don't freak out.
Yeah, so I mean, that's a good question. Fortunately for us, it wasn't a conflict along the way. That's only because the team really had to internalize this sense of trust, right? And I'm going to sound like a bit of a company man here spouting company values, but we have this kind of company value to be worthy of trust, right? And that's very heavily internalized in the software team. So for us, absolutely on day one, when we launch, we have to be at least as high performance as the existing system, and it turns out we're about 3 to 5 times faster on most of our metrics. And we have to be 100% durable. We have to be at least as available and durable as S3. So that meant kind of building trust within the organization, right? So it's all well and good to build this system, but then you have to actually prove that it works. And most of that came through this period of production validation where we literally sat down and we wrote this little contract, somewhat for fun, but it was a real, very serious effort where we wrote a contract with the founders, Drew and Arash, and we said ahead of time, this is the conditions we have to hit to be able to launch a storage system. So we're ready, we're running at scale, we have some significant fraction of our data mirrored onto the storage system, but the primary store is still S3. So this is what we have. These are the criteria we have to hit to be able to launch. And those criteria included stuff like running at absolute production scale for 6 months with no incidents, no major downtime, no data loss, no corruption, and a big suite of tests. So, physical, so software logical level tests, like, we had, people auditing the system, and we did injected faults, and we injected corruptions and made sure the system dealt with it gracefully. And also physical tests. We had people getting on planes, flying out to our data center and pulling out circuit breakers, while the system's running to make sure that it fails gracefully, or boxing up a rack and letting it overheat to all the servers crash, and then bringing it up again and making sure the data is correct. So a lot of physical tests as well. And so we went through this production validation phase, and that was a very fun time. It was very exciting to be doing all these tests, to be putting the system through its paces. On the whole, it was a very successful period. But one notable thing, so we have this software team. We're sitting in our little pod. We're working extremely hard. We're all motivated. And we had a big clock on the wall, and I'd put a big kind of countdown clock counting down for 180 days. And we were like, we have to hit 180 days of production service before we can consider this a primary storage system. And we got, about 30, 40 days into the countdown, and there was a problem. And so we noticed we have a pretty involved release process where you first push code to a staging cluster, and that staging cluster runs a mirror of production data on it. And we run all these verification systems on the staging cluster. And the verification systems caught an error. And that error, fairly obscure, won't go into details, but it didn't impact data safety, ultimately. There was no data loss. But we all felt pretty uncomfortable that a bug kind of got out to our staging cluster. And so then you're faced with this junction, right? You say, we didn't really break the rules of the contract. The contract said, data loss or major outages. We didn't have either of those, but we just didn't feel that comfortable in spirit going through the launch like this. So, I sent an email to the VP and I said, look, we're going to reset the launch clock. We're going to start again. And fortunately, Dropbox is the kind of company where I got met with a lot of enthusiasm, very enthusiastic response to that. This is absolutely the right thing to do. That was a very expensive decision. that was delaying launch for 1 to 2 months, which has very concrete financial and practical implications. But ultimately, we can't compromise on those kind of things. And I'm sure I could wax poetic for a long time about team culture, etc. But I think for us, establishing that culture within the team of like absolute confidence and correctness and trust, because no one wants to be involved in a storage system that compromises user data, right? We all have that. It's our personal integrity on the line, basically. So fortunately, that all worked out pretty well.
So there was no moment where Drew Houston came rolling in, pounded his fist on the desk like the NASA movies, and said, "I'm going on Bloomberg tomorrow. You're not relaunching the clock. Ship the system."
Yeah, we've still got our jobs, and we're all doing pretty well. So that it actually worked out great, and I think people were almost relieved that we had that clock resetting moment, because it could have all gone seamlessly, and we could have gone through the whole 6 months without issue. But then you had those unknowns in the background, and it was a good test of the team to have that issue happen, go back and invest more heavily in prevention mechanisms, and then reset the clock and launch it in a way that we all felt very proud of doing so.
That's great.
That's great. That's a really impressive story. I love that.
Great.
Well, listen, James, I think we're gonna wrap up a little bit. We're kind of hitting that time for the show. So I don't want to put any pressure on you. We've been a Dropbox customer for about the 6 years of the show. So, if you want the show to go out, we got to make sure you guys keep doing what you're doing. Keep doing it very, very well.
We got you back. Don't worry. That's my life. I live and breathe storage and data safety. That we think about that every day. So you're in good hands. Don't worry.
Very cool. Where can people find where you're going to be? Talking about the system. I assume you guys probably get calls all the time from potential clients and people that are thinking about doing big stuff. Where can people engage with you, or where does the team like to engage with the communities?
Yeah, so we have a few blog posts on the Dropbox Tech blog. So you can go to the Dropbox Tech blog and search for Magic Pocket. Every time we launch a new blog post, a few of us jump on Hacker News, and I always like to get pretty involved in those conversations. I find that the reception from the readers is really pretty positive once a few engineers jump on and start giving honest answers to questions. So always down to answer questions there. And I'm probably giving a talk at Facebook at Scale conference coming up pretty soon. But stay tuned on the blog. I think we'll have a blog post coming out pretty soon about kind of our next generation storage architecture, where we're using this new type of disk drive called an SMR storage. So there should be some more interesting details coming out there.
Very cool.
Fantastic. Awesome.
Well, listen, Aaron, you want to take us home?
Yeah, absolutely. So, James, thank you very much for all the information tonight. Really, really was great stuff and super interesting to hear about. On behalf of Brian and myself, thank you very much for listening this week, and we'll talk to everyone next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.